In this question, we are given the function y equals negative 3x squared plus 12x minus 9, which is in general form, and we need to use the tiles on the right-hand side and put them in the chart below to identify the characteristics of this function. So first let's start with the expansion or compression. Because the value of a is less than negative 1, we know that we have an expansion. So we'll move that into place. Next, because the leading coefficient is negative, we know the direction of opening is going to be downward. Now the vertex. Out of all the questions here, the vertex is probably the most complicated to answer. In order to do this, we need to complete the square. So let's give that a try. First, we'll start by writing down the function. Next, we need to take a look at our leading coefficient. In this case, our a value is negative 3, and we need to factor it from our first two terms. When we do so, we'll be left with the following, such that we have x squared minus 4x left in the brackets, and the negative 3 has been factored onto the outside. Next, we'll take our b term, which is negative 4, and we'll divide it by 2, and then square it to generate the additional values that go inside the brackets. When we do this, we'll have plus 4 and then minus 4. Next, this negative 4 term needs to be multiplied by our leading coefficient, negative 3, and it is brought outside the brackets. When we do this, negative 4 times negative 3 will give us 12. Gathering our like terms, 12 minus 9 will give us positive 3. And then finally, completing the square, x squared minus 4x plus 4 is equivalent to saying x minus 2 all squared, like so. So we have the final equation, negative 3 all multiplied by x minus 2 all squared plus 3. These two values here tell us our vertex is at the ordered pair 2, 3. Next, we can take a look at the domain. For any quadratic function, the domain is always the same. It is x is all real numbers. Next, we need to deal with the range. If we reference our vertex at the ordered pair 2, 3, we know that 3 is the maximum point. So that means all the points are going to be less than or equal to 3. So our range will be y is less than or equal to 3. The axis of symmetry is always equal to the x value of our vertex, so we'll have x equals 2. How many x-intercepts do we have? Well, if we take a look, and you imagine that the vertex is over 2 and up 3 units, but then it's opening downward, it must cross the x-axis twice, so we'll have 2 x-intercepts. Since this original equation was in general form, we know that the c value, our negative 9, is our y-intercept. So the y-intercept, we can drag the negative 9 into place. Finally, let's check to see if this function has a max or min value. Because the leading coefficient is negative, we know that the graph is going to be opening downward. So our vertex at 2, 3 is going to be a maximum point. So our max value will be y is equal to 3, which is the y value of the vertex. Let's check our solutions, and we are correct.